So here, to train the applications, you have machine learning. And also you have deep learning. Machine learning purpose is same, deep learning purpose is same. But when to use that one, when to use machine learning, when to use deep learning, some idea we need to have. Actually this deep learning, before this deep learning, you might have heard about this word, neural networks. This deep learning is simply an extension and modified behavior to the neural networks. That means we can say that a advanced to neural networks. So deep learning is an approach how your human brain is learning the things. Okay, in that style, the deep learning is going to learn the patterns from the data. So like you can say that is a simulation to human brain. Of course, not exactly. No one can 100% simulate, 100% make duplicate of the human brain. But we try to simulate human brain learning style here by using deep learning. But why already we have machine learning models, then why the deep learning models? So that clarity is important. So I try to explain with some picture. So I'm not good at this painting. Just I'm trying to explain, just try to understand. Think that the first circle is a feature of one particular classifier. Think that this is a classifier for male. This is a classifier for male. Think that these are the features of male features. And one more thing, there is another thing, the second circle, I'm sorry, the second circle I am taking. Think that the second circle, which is the features of a female, male features and female features like this. I'm trying to explain in a circle point of view, in a set theory point of view. Suppose a small example, even you can question this for your kid also. Like if you present two pictures, one male picture and one female picture, and if you ask your baby or if you ask yourself, who is this, male or female? That is what our final prediction. So simply we can say that this is a male, this is a female just by seeing the picture. So how easily you are able to say that? Because the basic reason is, if you treat that left circle as a male feature in appearance point of view and right circle is a female feature, there is very less common features. The common features are less here. Distincted features are more. Okay? The distincted features are more. That's why just by seeing the pic, without doing vast computation in our brain, immediately you are say that the picture number 1 is a male, picture number 2 is a female, and picture number 3 is a male. Like this you are able to predict the things. Okay? And so for this kind of problems, machine learning will solve all these kind of situations. And one more example I try to explain. Observe the things. I am presenting you two pictures for you. One is a male rabbit and next picture is a female rabbit. Just by seeing the picture, can you say which is male, which is a female of the rabbits? We cannot say. Why we are failing in, why we could not able to say in that particular situation is, if you take male features of the rabbit, female features of the rabbit, in appearance point of view, not physical body point of view I am talking. Okay? Appearance point of view, there is 98% commonality between feature 1 and feature 2. Sorry, classifier 1 and classifier 2. Think that this circle is male and this circle is like 1 minute. Yeah. Now observe this. This is the second circle. The second circle is for female. First circle is for male. How is the commonality now? Between these two classifiers, the commonality is 95% or more than 90%. Okay? So distincted features are very less here. If distincted features are less, commonality is very high, our human brain will be failing to recognize it. That means the simple models of machine learning will be failing to classify that one. In such cases, you need powerful models. Okay, in a typical situation, you need to train the model. That is what? Deep learning. The deep learning follows same as human brain learning mechanism. Got it? So the same point I will be writing here. The machine learning is used for simple predictions. And the next thing, the word deep learning. The deep learning is for complex predictions. Simple predictions and complex prediction. Here, what do you mean by simple prediction and what do you mean by complex prediction? Same as the previous circle examples you can say. Between classifiers, commonality is less. Distinctive features are. So then machine learning will help. And here complex prediction means same opposite I am writing. Between classifiers, commonality. Commonality is very high. That means the distinctions, the distinctive features are very less. So that means more than 90% common features and some 10% might be, 10 to 5% might be the distinctive feature our human brain could not able to recognize just by seeing the shape. So at that time you need to apply deep learning. Okay. And what is the importance of NLP in this book? So NLP can be used with machine learning, NLP is used with deep learning. NLP is the common element between these two things. And nowadays, most of data is unstructured data. But within that unstructured data, a lot of useful information is available. Okay. Suppose for your restaurant or for your product service, okay, a lot of customers are there. These customers are giving reviews in different review sites and in different social media sites like that. So you want to understand what is the sentiment of your users. That means your customers, whether your customers are satisfied customers or not. Okay, such kind of things you want to understand. But the given review is not structured. The given review is purely unstructured. So so here NLP is not to train the model. NLP is to pre-process the text. Okay. So pre-process means data cleansing activity of the text and data preparation activities like feature extractions of the text. Such kind of pre-processing will be done by the NLP. Once numerical features are extracted by using NLP, then the models have to be trained by using machine learning models or deep learning models. Got the point? So just a minute. I am writing the same thing. NLP stands for natural language processing. Is to pre-process the text. Okay. So that means extracting numerical features from the text. Once features are extracted, so train the models using ML approach or DL approach. Again, when to use ML, when to use DL, already I told you. Suppose especially our text is the chart, our chart data. Okay. So within the chart, generally we use informal languages. That means that is what complex predictions. So if it is an email, if it is like a company emails, mostly we use formal languages. But if it is chart data between you and me, we use informal kind of things. So which is having typical patterns. So especially to train the model based on chart data. So we need to go with deep learning kind of things. If it is normal, we can go with machine learning models like SVM or decision tree, random forest, for such kind of things that you can use. Okay. Simply, already here I given clarity. If common features are high between the classifiers, then deep learning. If common features are less, distinctive features are more, you can go with machine learning. So once features are extracted, we need to train the models using ML approach or deep learning approach. Now think that your application is embedded with ML models. Your application has trained models by using ML. Then what your application can do? Your application almost all simple predictions, your application will be automatically doing that one. Suppose in our application is trained with even NLP models also, ML with NLP. Now your model can understand structured things and also unstructured text kind of things also your model can understand. But still your application is missing something. So complex predictions it could not able to do. Again, to do the complex predictions, you have to embed deep learning models also. Now whatever application can do simple things and complex things, even your data is unstructured, it could able to understand, it could able to extract the features, and already trained models are there, so that if you give some unstructured text, automatically your application will understand what is the meaning of your text. Okay, whether your customer satisfied customers, whether customer is talking positively or negatively, everything your application can understand it. But still your application is missing something. Self-learning behavior your application is missing. Observe this, by using ML, you trained about 100 different patterns, and by using deep learning, another 100 different patterns. Totally now your application could able to understand 200 different patterns of simple and complex things. But tomorrow, if new data comes, if that data is not having the behavior of existed patterns, then your model cannot say anything, your application cannot say anything. Okay, that means self-learning is missing. With how many patterns I trained the model, my application limitation is within the trained patterns only. Beyond that, it cannot think it. Okay, so now I want to inject self-learning behavior into application. So for that, artificial intelligence. This is to inject self-learning behavior into applications. That is what here artificial intelligence. Once artificial intelligence was used only with robotics, now that is being embedded into application itself. So in this way, ML, NLP and deep learning and plus artificial intelligence. Okay, the integration of all these three things into your application makes your application smart. That means it's a simulator as a simulator to brain. So such kind of application is deployed into production. The production will be exactly behaving like a human. Okay, except eating, walking, sleeping and remaining all other regular activities, the application will be doing even complex predictions and complex things. Generally what your human brain cannot recognize it, such kind of things also your application could able to recognize it. So for this, a simple example, sir, very close example, where exactly all these things have to be implemented to understand it. I am taking a movie of Robo, sir. It's not like real Robo. It's a movie. A Rajnikant's Robo movie. You just take it, sir. So here, who is the data scientist in that movie? Mr. Rajni was the data scientist. He trained a Robo in the beginning. Okay. So he trained Robo in the beginning by using machine learning, and also he embedded NLP so that the initial Robo in that movie could able to do simple things and also could able to understand unstructured text data. So it is listening people voice, the voice is converted into text. From that converted text, it can understand what is the sentiment of the person. According to that, it takes proper decisions. So it's all the things by machine learning and NLP. After that, this robo went for some army testing. But within that army testing, this robo was rejected. What's the reason is, could able to do only simple things, but could not able to do complex things. Because of that reason, in that movie, this robo was rejected. Okay. So for that, later what has been done? Mr. Rajnikant, who is a data scientist here, or who is a scientist of this robo, who created this robo, has embedded deep learning into this one. Now the latest robo could able to do small things and also complex things. What are the data pattern or data shape like structured or unstructured, could able to recognize it. Okay. After that, what happened is, after interval of this movie, somebody villain into that movie, he added artificial intelligence into that system. Then self-thinking started into that robot. Emotions started. Okay. Love started, angriness started, all the human emotions little started into that robot. Okay. Then it became against to, slowly it became against to Rajnikant. Right? After that, finally, artificial learning is embedded into that one. Artificial learning. Artificial learning means one trained application will make will train other applications. So in that movie, what happened once artificial learning implemented? The robo number one is making robo two, robo three, robo four, like this. A number of rows it is making. There is no involvement of the initial scientist to make this robo 2, robo 3, robo 4. This trained robo is making these robos. This is what artificial learning approach. Okay. So in this way, if you look at that movie of robo, okay, so indirectly you can understand what is a machine learning, NLP, deep learning, artificial intelligence and artificial learning. So where exactly all these things are embedded into that one particular application. Here application means that robo is the one single application. But this single application contains all these models. Okay. This is what like exactly a data scientist role. Okay. Of course, especially presently market not at reached these artificial learning models. Presently the industry is got reached up to machine learning, NLP, deep learning and artificial intelligence. Maybe by 2020, artificial learning will also play a role into the applications. Okay. So this is what like a simple understanding about machine learning purpose and deep learning purpose, when to use what. Got it? So these are the different sub-disciplines. But to understand all these things, you need some prerequisite. The prerequisite is the statistics basics and R language and Python. Already I shared you the R and Python videos for you, especially NumPy. NumPy is major role here. And tomorrow one more session I need about this machine learning. But tomorrow session already, tomorrow whatever I want to say, supervised learning and unsupervised learning approaches of this machine learning. That recording I will be sharing with you. Okay. So what's the plan of tomorrow? I will be confirming by afternoon, sir. Okay. Let's see in the next class. So I recorded this one. I will share you this recording by afternoon, sir. Thank you very much.